Hello and welcome to this video tutorial explaining how to do the configuration and control of iseg high voltage power supplies with the new iseg communication server in version 2, in short called iCS2. You can start easily with the use of a current web browser. If you want to use a Windows system to get access to the iCS2, you can easily find this as a local network location. To do this, you have to open the Windows Explorer and navigate to the network. Here you should be able to see ICS entities if they are connected and available, and you can directly open them with a double click. This will open the logon screen. If the ICS entity is not shown under network locations, and you do not know the IP address of the iCS2 you are using due to this is configured by using the DHCP functionality, there is a helpful tool on our website www.iseg-hv.com. Under Support Download, you will find a button to get access to our FTP server, on which you will find the tool in software iCS. The tool is called iCS Finder. After a download of this tool, there is no installation necessary. You can directly start the extracted file with a double click on iCS Finder. This tool will then show you an overview of all iCS2 server entities found within the local network, including their IP addresses. With a double click on one of the shown servers, your standard web browser will be used to open the connection to this server, and you will see the logon screen for this particular server. Within the URL line, you can again see the use IP address. The factory settings for the credentials are admin for the username and password for the password. You can then choose to use an English or a German language version of the server. When starting the server for the first time, the system will prompt the message, "No device configured, please check ICS config." So the first step is to do a hardware configuration with ICS config. To be able to do the configuration, you have to manually start the crate hardware by pushing the power on button on the front panel of your crate, which is not shown here. After waiting for some seconds, you can do a rescan of the hardware with the corresponding button. You will have to confirm that you want to do a rescan. After a rescan, you can start the automatic configuration with the corresponding button. An existing configuration would then be replaced, but if you are doing this for the first time, it will just create a new configuration. After a short reload, the automatic configuration will be finished, and we can see for the setup used in this example that the system has detected a master controller and for each of the slots of the crate one high voltage module, including the serial number. In this example case, the high voltage modules have been manufactured already some years ago, and the type of module cannot be detected automatically. Therefore, to be able to also use earlier versions of high voltage modules, it is possible to select the module type manually. This can be selected in the field Model. In this example, the module within the first slot is an EHS F410P-F without the L option. and the second module is an EDS-F330N. The module type can be found on the front panel of the corresponding module. For the controller itself, it can be selected that it is working within an ECH242 crate with 2 slots. After this, the configuration can be saved with the corresponding button Save. After a quick reload, you will be able to see that the configuration has also received little icons from the product database, which are representing the used modules and crate. So you can compare that the products you have selected are really the units you are using. After the configuration is finished, you can switch to the control of the system with a click on iCS Control in the upper left corner of the window. In the middle of the UI, you will at first find some quick hints regarding the use of iCS Control. In the left column, you can navigate to a specific hardware of the system. Depending on the selected hardware, the available channels of this hardware will be displayed in the main area of the UI. In this example, the master controller was selected, and therefore all of the channels corresponding to this controller are shown. These channels can now be monitored or edited. In the overview window for each channel, you can see the specific path of line, module address and channel. You can see if the channel is switched on or off, the set voltage, the measurement voltage, the set current and the measurement current, as well as some additional information regarding the channel. In the right column, you will find an overview of information about the selected hardware, and you can change specific settings. As an example, due to we have selected the controller, with the use of the power option, we can shut down this specific controller. This also means that all high voltage channels connected to this controller will be shut down, and they will be faded out in the main control window, due to it is not possible to control them as long as the controller is shut down. You will be able to see the last settings and the last events. For every piece of hardware, but also for every channel, next to it on the left side, you will find a color-coded display giving a quick overview about the status of this hardware or channel. It will be displayed in one of the 4 colors: gray, yellow, red or green. Gray is corresponding to switched off or not available. Yellow corresponds to the hardware or channel has not reached its setting values yet, for example during a ramping process. Red is indicating at least one error message, and green is indicating flawless operation of a hardware or channel according to the selected setting values. So in this example, the gray colored bars on the left of the serial numbers of the modules inside of the system indicate that these modules are switched off right now, and you cannot do any changes of the settings or switch on individual channels. Next to the selected hardware or channel on the right side, you will find a badge which is also color-coded. These badges are giving a quick overview about events, indicated in yellow, or errors, indicated in red. In this example, you can see the badge showing 24 events. With a click on the badge, you will get a detailed list of the detected events, which are in this example case the end of ramp for all channels within this selected crate. You can see that you get detailed information about which device, module and channel the specific event is regarding to, as well as a timestamp. This can be reset with the button Clear All. In this specific example, it is not possible at the moment, due to the crate controller is still switched off, and it is therefore not possible to send the Clear All command to the modules. If we switch on the controller again, the connected modules will also get back online and will also clear the former events. The whole process will take some seconds for the system to restart. After the modules are back online, the badges are gone due to we have pushed the button Clear All before, and it is possible again to change the settings of channels or to switch them on or off. In the main area of the UI, you can now see all channels connected to the selected controller. If instead only the first module is selected in the left column, the main area will also only show the channels within this module, and the right column will only show information about this specific module. In the overview window, it is possible to switch on single channels directly with a click on the off button. With a click on the icon next to the setting voltage of a specific channel, a settings dialog for the voltage of this channel will open. Here it is possible to enter a value directly or to use a slider for the settings. At the same time, it is possible to monitor the actual output value of the voltage. For this to be changed, you have to push the button Apply. Additionally, this dialog offers the setting of an additional parameter called VCT coefficient. To be able to use this parameter, the module has to be equipped with the VCT option, which is voltage control by temperature. VCT offers the possibility that the channel is automatically changing the output voltage following a specific coefficient depending on the temperature, which is measured by an external temperature sensor. This parameter is deactivated if the module is not equipped with this option or the external temperature sensor is not connected. After the requested value for the output voltage was set, the dialog window can be closed and we can see the set output value within the overview window of the selected hardware. To set several channels to the same value, we can select those channels with the marks on the left, and with a click on the icon directly below the label VSet, a setting dialog for the selected channels will open. This dialog is looking similar to the former one, except that the output value is not displayed. Here again we can set the requested values, and after clicking Apply and closing the dialog, we can see the changed settings within the overview window again. It is also possible to switch on all of the selected channels with the button On in the top row directly below the label Power. To select all of the channels which are displayed, the Select All mark in the top row can be used. Then all channels can be switched on or off, or the specific settings can be changed for all channels at the same time. This is of course not only valid for the voltage, but also for the current settings. With the icon in the top row, a dialog for all selected channels will be opened, and with a click on the icon next to the current set value, the dialog only for this channel is opened. Within this dialog, it is also possible to edit an additional parameter, which is the delayed current trip. Other functions which can be used for selected channels are, for example, the channel folders and channel profile functions. You can find these next to the Select All mark. Channel folders, which can also be seen in the left column, offers the possibility to group specific channels, also from different modules, inside of a folder. This folder can then be freely named or added to an existing folder. In this example, we create a new folder, Test folder. We cannot add it to another folder because there's none existing. After the creation of a folder, this can be selected in the left column, and changes of the parameters only for those channels are possible quickly. Channel profiles, on the other hand, offers the possibility to save or set specific combinations of parameter settings for several channels. As an example, here we are setting channel 1 to 400 volt, channel 3 to 40 volt, and we are switching off channel 4. This specific combination of parameters can then be saved with a click on the icon channel profile. Again, a specific name can be chosen, or these parameter settings can be added to an existing profile. For this specific example, we will name the profile test profile, and we will create a new one, because we cannot add it to an existing one, because they are non-existing yet. In the column on the left side, it is then possible to choose a saved profile. To demonstrate this function here, all of the settings for those channels are changed, and afterwards the test profile is selected and applied, and all of the former settings are set back to the saved values within the profile. Another functionality the browser-based ICS control is offering is a graphical presentation of measured values of selected channels. This is working in the same way as changing setting values for a group of channels. The channels which shall be implemented into the plot are selected, and then the icon for plotting of voltage is clicked. Of course, it is also possible to show the measured current values instead. For this, the icon below iMesh has to be clicked. The plot is then showing and updating according to the measurement values at this moment. The data shown here in this example is coming in real time directly from the client. In future versions of this software, it will also be possible to retrieve stored log data of previous sessions and present them graphically. The current values shown in this example are very low, due to there is no load connected to the channels. The visible spikes are the charging currents from when we switched on those channels. Another functionality is the display of live log data, which can be accessed in the right column. Again, this is according to the selected channels, and then activated for the voltage values with the right icon under vMesh. Now only the live data for those two selected channels is presented. On first sight, it is only showing the last measured value, but with a click also prior measurement values are displayed with a timestamp. So if you click on the measurement value of one of the channels, you can also see all of the prior values within this session. It is also possible to do a CSV export of the measurement values of the selected channels, which can then be opened with Excel or another spreadsheet program to get additional ways of analyzing and visualizing the data. The feature Commands offers an additional possibility to directly change settings of the hardware. For this, select the hardware of which the settings shall be changed, and then under Commands a list of quick commands to change the specific values can be found, like switching on or off all channels or modules, change the ramping speed of all channels or modules, setting of kill enable or emergencies, or the activation or deactivation of fine adjustments. Instead of taking a number of several channels, it is also possible to enter direct paths to specific channels. In this example, we will be addressing the 5th channel of module 0 on line 0, and will change the setting voltage for this channel. In the list, all of the channel items can be found. We can then set the requested value and the unit of this value. With a click on Set Item, this specific value will be changed, as we can see in the main window. With the use of a wildcard in form of an asterisk, it is also possible to address all modules and all channels of a specific CAN line to be affected by this setting change. As we can see, all channels have changed the value for the set voltage, and the channels which already have been switched on also have changed their output voltage. Let's get back to ics-config with a click on the ics-config button in the top row. This is used to change presettings of the used hardware and the configuration of hardware setups. Within the left column, many sub-items for different settings of the ics-config and different services the ICS is offering can be selected. Under the first sub-item ICS control, the presettings for the integrated control can be changed. This is, for example, regarding sound feedback, or a USB camera to have a visual surveillance of the system itself can be configured, and settings for the Websocket or HTTP polling can be changed. The second sub-item hardware we have already used to configure the system. Our example system here only consists of a 2-slot crate with a master controller and 2 high-voltage modules. In larger setups, master controllers are also indicated with a blue stripe, and all connected slave controllers are shown within their connected CAN line, 0 or 1. According to the selected hardware, you will find specific information regarding this hardware the server has detected, which can be integrated into the current configuration with the button Apply Config. When detected information and set information are equal, you will see the green label Config OK. On the far right, specific device settings can be changed. For example, for the selected controller, the title and the CAN bitrate could be changed, or the handling of specific events as either an event or an error. In the first row here, we can select if a detection of the mains voltage out of the accepted values shall be shown as an event or as an error by the server. If we select a high voltage module instead of a controller, we will see that there are different presettings, like the value for the digital filter or the sampling rate of the ADC. And also different events than for a controller can be configured regarding if they either shall be shown as an event or as an error by the server, or for some others if they shall be shown as an event or if they shall be ignored. For example, for the end of a ramping process, the switching into constant current mode, if the safety loop was opened, if there has been an input error, if the supply voltages are too low or too high, or if the temperature is too high. If there is a physical change of your hardware setup, for example by adding more modules or taking others out, it is always possible to adapt your configuration with a rescan and the automatic configuration of the hardware. Auto configuration automatically includes newly detected hardware into your existing configuration, and this can then be saved. Another sub-item of ICS config is the configuration of the Ethernet settings according to your network settings. For example, the use of a DHCP client or the setting of a fixed IP address, mask, DNS server and gateway. The next sub-item is the configuration of the Wi-Fi adapter. Any master controller can be working with a Wi-Fi adapter to create its own Wi-Fi network for easy access. This can also be deactivated via software here, or also physically by detaching the Wi-Fi adapter from the controller. If you decide to use the Wi-Fi functionality, the IP address of this Wi-Fi network will be fixed. But you do have the possibility to change the SSID, the Wi-Fi channel and of course the password. The factory settings for the SSID are iseg-ics2 and the password is password. iCS2 also offers an extensive users and roles management. The factory settings for this are an administrator user with the password and a demo user. To change the settings, click Edit and a dialog to change the settings will open. In the next sub-item roles, the users can be assigned to specific roles, which will become important under the next sub-item access control lists. Under the sub-item Access Control Lists, it can be specified which users and/or roles can or cannot do specific actions within the system. So, for example, it can be specified that only some users can change voltage or current settings of individual channels or clear event messages. This means it is possible to offer a monitoring access, but without any rights to change settings. iCS2 is offering several software services to access the system with different control software. For example, iCS2, which is the application programming interface for the iCS control software. iCS2 is offering a Websocket-based or HTTP-based interface. Via the Websocket-based interface, commands can be prompted bidirectional via push and pull, and via the HTTP interface, the software client can periodically check the status and value of specific items on the server. For example, it would be possible to receive the serial number of a specific module with the use of an URL, which we will show in this example. Within the URL, at first comes the IP address of the server system we want to address, /API/getItem/API key. The API key you will get after you have done at least one login for this system and session. Following that, the path to the specific module is given with CAN_line/slot number. In this example, CAN line 0 and slot number 1. The channel number within the path is replaced with null because it does not matter for the serial number. This is given to modules only, not individual channels. And finally, we enter the item we want to get, which is in this case status.serialNumber. The response you will get by using this URL is then including the serial number and the timestamp of the module, which can be found at CAN line 0 and slot number 1. An overview about all the items which can be requested you will get on the URL IP address of the system /API/getItemsInfo. This will lead to an XML file containing all available items structured with device items following module items following channel items, each with a description of the data type and what the item is used for in English and German. In this field you will find several examples of URLs to explain the usage of the system with a description of each example. One example also shows that it is not only possible to get values of specific items, but also to set them. In the example shown here, the output voltage of the channel at the position CAN line 0, module slot 1 and channel number 2 is set to 2999 volt. Additionally, it is possible to use a SOAP interface, of which a detailed description you can find under this link. iCS2 is also equipped with an integrated EPIX input-output controller, or short EPIX IOC. Here you can change the settings for the automatic start of the IOC, or you can directly start, stop or restart the IOC. The necessary configuration files for the use with EPIX can automatically be generated according to the specific setup by the iCS2 server with the button Generate Configuration. The first file is the iseg_epix.database file db, which is containing all definitions of process variables. The second file, iseg_epix substitution file, or .sub, is containing a list of all detected channels, which is created with a click on Generate Configuration. Then iCS2 is creating a new substitution file depending on the current system configuration. After that, the Epix IOC can be restarted, and this will create a list of all process variables which are generated by the IOC. This list can be downloaded and opened with an editor to get an overview about the items which can be controlled. All three types of files can be downloaded, edited according to your requirements on an external system, and then uploaded back to the iCS server. This offers the possibility to save and edit several different Epix configurations. More details regarding Epix and Epix IOC can be found in the manual or by contacting our support department. These functionalities are not yet available, but soon we will also integrate an OPC-UA server and an SNMP interface to be compatible to already used iseg systems as well as Wiener import systems. iCS2 also offers an easy-to-use update functionality. In the upper part of this sub-item, you can see the currently used product database version as well as the ICS version. If connected to a network with internet access, it is easily possible to check for updates online with the push of a button. In this example, an update file is available, and the link to this update can be downloaded from the iseg repository folder. It can then either be downloaded directly to this specific server system, or as a file first to be able to do the update later or on a different server system. If you want to do the update later, you have to specify the storage path in this field. Thank you for watching this tutorial. If you would like to test an ICS system yourself, this is possible by accessing the URL ics.iseg-hv.com. Please do not hesitate to contact us via phone or email in case you have any questions. Thank you and bye-bye.